We had to do every other odd.
Every other odd.
Yeah.
Okay. And I get things confused. Now you'll have to do the annotate thing on your side, but
Oh my gosh.
is it Zolman? Is it Nicholson? Who is it again?
Zolman.
Zolman. Okay.
Enable annotations, hide names of annotators. Okay. All set.
All right. Well, find the amplitude of the function and use the language of transformations to describe how the graph of the function is related to the graph of y equals sine x. So, has he talked much about or used the term fireproof form?
He hasn't said it at all. This, I know what it is, but he specifically hasn't said it. But he also hasn't taught 404 yet because we haven't been in class yet.
Okay, so for a sine function, it would look like this. Now, in the particular question number 1 that we're dealing with, h and k are both zeros, which is why you don't see any numbers there. You don't see anything that's being added either to the x or to the y. Nothing's being added or subtracted.
Okay.
In fact, I see that the a value is equal to 1. The only thing that we have here that's different is the b value. And so your fireproof form is pretty easy to come up with. It's just a matter of dividing by 2 on both sides. Does that make sense? Well, because the truth of the matter is, let me ask you, what number do you see right here underneath that x?
Nothing, so 1.
Right.
Okay.
It has to be a 1. Okay?
Yes.
Because I don't see anything written there. So, the b value is 2. Okay, now did he talk to you about graphing this function right here at all?
No, I don't think so.
So do you know how to graph the wave of a sine function, or is that completely foreign to you?
That's foreign, but I feel like in the past we've in previous years we've done it. Maybe.
Okay. Can you do me a favor and open up a tab and go to Desmos.com?
What?
Actually, you know what? I'm going to do that. I'm going to... I'm going to share screen because I want a particular... Oh! Have I told you about my shirts?
I don't think so.
Okay. Inside your... let's see. Let's find you. So, if you ever go to your videos, right up here at the top, I have this information. Now, have you ever read that?
I haven't.
Okay. Well, so there's the link, and now what it would take you to is I actually have I take my unusual sense of humor, and I put it in. Let's see if I can find my store. Come on, where's my store? Dashboard. Okay, let's find my store. This actually came from. So as you can see, I just made a statement in class, and some kid said he would buy this shirt if I made it. Now, whether he did or not, I don't know. But let me find. How do I need to get to my store? How do I get to my? I don't want to edit the store. I want to go to the store. Okay, let's go here. Okay, view store. So everything that I create and everything that anybody buys on my site is then the profits are donated to a youth center here in Allen County in honor of my daughter. But I take my unusual sense of humor and I put it in. Some of them are math related. Some of them, like the second one from the left there, is Star Wars. That's Han Solo. You know, I mean, obviously the far right, you probably understand where that phrase comes from, and obviously I made it into a car theme. Or do you not know that phrase?
Am I supposed to know that phrase?
Well, if you take the F out of shift, I'm sure you probably have heard it.
Yeah.
Okay, all right. So I just take my unusual sense of humor, and I mean they can be like you can if you wanted the one on the right, I call my toilet gym, or I call my toilet gym so I can tell people that I go to the gym every morning. Well, if you instead if you didn't want that as a cup, you could come down here and you could make it a long sleeve T-shirt. You know, I mean,
That's
so it doesn't have to be just a cup.
yeah.
But anyway, so I just take my unusual sense of humor and I put it on, all these things. And
I
so,
love it.
yeah, so, I don't, it would be nice. Okay, where is it? Where is it? Okay, where did I put it? It is, oh yeah, this one. Now I don't know. Do you know what FEMA is?
I don't.
It's called Federal Emergency Management, and I don't even know what the A stands for, but, you know, so they're currently setting up camps in Washington State that are supposed to be for COVID patients. It's the federal government, and so I obviously stole that phrase from a movie. This one time at band camp, but anyway, so it's just more of a political satire
Got
type
it.
shirt.
Got it.
Anyway, that's that link's in there. If you ever want to just go, have a good laugh, you can go in there and look at my designs.
I will for sure.
Yeah. In
Thanks
fact,
for
I had
sharing,
I
man.
had one of my students today said, "Can I post this on my Instagram?" I'm like, "Okay, sure." It's like,
Yeah.
all right, not a problem. Okay, now where were we? We were over here. I want to go here and go to Desmos. There we go. Okay, so y equals sine x. Now, does that number look familiar to you? Pi?
Yeah.
Okay. What about that one? 2 pi.
Yeah.
Okay.
3 pi.
Yeah, over here would be 3 pi. You're right. Okay. Now, you'll notice that the scale is based on the integers 1, 2, 3, 4. So pi looks like it's just, if I zoom in a little bit, you'll see that pi is just a little bit to the right,
Yeah.
right? Just a little bit to the right of 3, which makes sense, right? Because, pi is,
3.14.
yeah, right. And then if I double that, it's just a little bit past 6, 6.28. Now I'm going to change the scale here, and I'm going to change it. I'm going to make the x scale go by pi over, let's say pi over 4. Pi over 4. Okay? That's one of the nice things about this is it changes it to something. Let's see. Let's clear that off. Now, where does this come from? Well, maybe I should. I wonder if I could do that. Ooh, yeah. X squared plus y squared equals 1. You are familiar with a circle, right?
Yeah.
All right, so that's the equation of a circle. Sine. Are those x values, y values, or slopes?
Sines are y values.
That's right. They're y values. Well, this is 0 degrees.
Yes.
Okay, or 0 radians. What happens, and what is the y value? So looking at this coordinate sitting right here at the edge of the circle, what is the y value at 0 radians? What is the y value?
0.
It is 0. Right. Which means that puts a coordinate right there at 0, 0.
Yeah.
What is the y value all the way at the top of the circle, which is the angle measurement pi over 2? What is the y value?
1.
Correct. Now, as a coordinate on the graph, that puts that coordinate right there. Pi over 2, comma 1. Well, what happens when I get to pi over here on the circle? What is the y value at that spot on the circle?
0.
Back to 0. That's here.
Yeah.
And then if I continue this process, I would end up with 3 pi over 2 would give me negative 1.
Yeah.
2 pi would give me back to 0. This creates what's called a sine wave. And as you go around the circle, marking the y values, and we can go around and around and around and around, which would create more and more waves. We can go in the negative direction, we can go in the positive direction, but we end up getting this shape called a sine wave.
Okay.
Now, the period of the function. Well, period means the length it takes to complete one cycle. So that's the length to complete one cycle. Well, that's 2 pi normally, right?
Yeah.
So we do have to multiply it by the absolute value of the stretch factor. But in the case of a sine function, right, the a value equals 1, therefore there's no stretch or shrink. This particular sine function is just a plain generic sine function.
So 2 pi
Times 1 is still 2 pi, right?
times the absolute value of 1.
Yeah, absolute value of 1, in case it's a negative multiplier.
Yeah.
Now there's something else called amplitude. Amplitude is the distance from what we call the center line of the wave, which in this case, the center line, that's the k value, y equals k. For our particular, that's what we call the center line.
Center line, which is k.
Y equals k, right? It's a horizontal line. It goes right through the middle of the wave. In our particular situation, when the k value is 0, that means we have y equals 0 for this particular situation. Okay,
so
go.
What is amplitude? The distance from the center line to what?
To the highest point, and the distance from the center line to the lowest point.
Okay.
You can use either one, but you can see from our graph that the amplitude is, we actually list it out as the absolute value of b. And the reason we have to say that is because the original, should I say the OA or the OG?
What do you mean?
So the OG of amplitudes, that's how I'm gonna call it that in class. The OG of amplitudes is 1. And the OG of periods
It's 2 pi.
is 2 pi. I am gonna do that. That's gonna be hilarious. Because they'll be looking at me like, what is he talking about? I'll be like the OG. The original gangster.
Oh gosh.
Mm-hmm.
Oh gosh.
Math teachers are cool people. If they want to be. If they want to be. The rest of them are just nerds.
Got it. Got it. Noted.
Okay, so since the original amplitude is 1, then the stretch or shrink is the thing that's going to affect it. Suppose we stretched it by 5, then the amplitude would be 5. If we shrunk it by 1/2, then the amplitude would be 1/2. Okay. And that's only because the original is a 1. Okay, so I mean, I guess I could put a 1 in front of the absolute value bars, but you know, big deal. It's not going to do anything.
Okay.
Now, how do I go about graphing these points? I will tell you that this right here, that coordinate right there, is my HK value. And in our particular case, the OGHK is 0, 0. Okay. Now, trust me, at first when you start seeing all this, you're like, what the heck is all this? But after a while, it's gonna make more sense to you. So trust me, I understand that there's a lot of things going on here, which is why it'll make a lot more sense probably the second and third time you've heard it. Okay? I always graph this point first.
Okay.
I always graph this point on the far right second.
Okay.
Because between those 2 points is the period.
Yes.
I graph this point third. Now, those 3 points are all on the center line of the wave. 1, 2, and 3 are all on the center line of the wave.
Mm-hmm.
So once I establish the end of the wave, then I go halfway back to find point number 3. Point number 4 is found halfway between those two at the top of the wave. And point number 5 is found here at the bottom of the wave.
Got it.
Now, what would cause the whole thing to flip over so that it was doing something like
A negative.
this? Yeah, a negative multiplier. In fact, I can come over here and I can prove it to you by putting a negative sign in front of it and watching the whole graph flip.
Yeah.
Okay? But so this is what we call the original sine function. Now he asked you to graph y divided by 2. Now before I put the 2 in there,
Wait, it was y divided by 2?
it is y divided by 2. That is the first question you gave me. Yours.
Right, 2 sine of x.
Ah, right. But remember when we put it in fireproof form? When we put it in fireproof form, that was y over 2 equals sine x. So in other words, it's the same exact thing. Okay, now my question is, we see now that this has a b value of 2. Is that going to change the period or the amplitude?
Wait, say it one more time.
Since the b value is 2, right, we can see that it's been a b value of 2. Is that going to change the period or the amplitude?
Amplitude.
That is correct. So when I put the 2, I'll better click back on there because it's not. You're exactly right. The length of the cycle did not change at all. Only the amplitude changed. The HK point did not change. The length, so point 1, 2, and 3 stayed exactly where they were.
Yeah.
Only 4 and 5 got changed.
Yeah.
But you know, when he asked you to graph that, I'm sitting there thinking to myself, well, if she doesn't know what the original sine function looks like, how is she going to graph? How is she going to stretch it vertically by 2?
Yeah. Okay.
So, if you ask me, I'm gonna clear all this out here for a second. If you ask me to graph y equals 2 sine x, the first thing I would do is maybe a little bit of algebra. I would see that the b value is 2. I would see the a value is 1. This tells me that my period is going to be what?
2 pi.
Just plain old 2 pi, because you're not stretching or shrinking anything. My amplitude is 2. So
And then
How about my HK? What's my HK?
0 and 0.
That's right. So I'd find this point right here. I know that my center line of my wave is right down the middle because that's y equals 0. I'd go all the way to the end, 2 pi units later, and mark my point where it's going to start over again. Halfway in between, I'm plotting that point right there. So 1, 2, and 3 have been plotted. To get 4, notice I'm going to come over here to pi over 2, but I'm going to go up to find that point right there. And in between pi and 2 pi, I come to there and I come down using the amplitude. And then I can draw my wave. Whoa. But that's how I would graph that.
Okay.
I need to know where this point is. I need to know what the period is so I can find this one. Once I do that one, this one's pretty easy. 1, 2, and 3. 4 uses the amplitude here, and 5 uses the amplitude between those two. And then I can draw my curve.
It's a vertical stretch.
Yes, it is a vertical stretch by 2.
But it didn't stretch.
What do you mean it didn't stretch?
It only got higher. It didn't stretch out.
Well, no. It stretched. The points got stretched up and down. In other words, the distances got doubled away from the x-axis. Everything got moved away from. It's true that you didn't stretch this way, right? There's no horizontal stretch. It's just a vertical stretch.
Got it.
Does that make sense?
Yeah.
Okay. What's your next equation?
Y equals 0.3 sine of x.
Y equals 0.3 sine x.
7.3 sine of x, yeah.
7.3?
0.73 sine of x.
Oh, 0.73. Okay. All right, so that's y equals 0.73 times...
And it wants me to find the amplitude and then the language of transformation.
Well, I'm going to ask you to find the period also.
Okay.
So actually, you know what I'm going to have you do first? This is what I have all my students do. I want you to find A, B, H, and K. So I want you to identify those 4 things. I've got it in fireproof form right now.
A equals... Oh, wait, hold on. Let me write down the fireproof really quick.
Okay. And do you understand the generic form of that?
Over 0. Yeah.
Okay.
Equals sine x. Okay, so the A is 1.
Yes?
The B is 0.73.
Yes.
H and K are 0.
That's true. Okay. So, what's the amplitude?
0.73.
Nice. How about
so
your...
amplitude is always the B value.
Amen. Now, if the B value is negative, remember, amplitude is a distance. That's why there were absolute value bars around it. So if they throw a negative multiplier at you, the negative causes a reflection, but it does not change the amplitude.
Okay.
Okay, so what about the period?
Just 2 pi.
Correct. So I'm going to find HK. All right, so there's point number 1.
0 and 0.
Now what?
And then halfway is 2 pi. No, sorry. The full way is 2 pi.
Correct. The full
And
wave is
then-
2 pi.
And then you put a dot on pi.
Yes.
And then you put a dot on
So halfway at pi over 2.
is 0.73.
Yeah.
And then negative 0.73.
Over here, yes, that's true.
Got it.
Okay. So using the language of variation, what would you tell me?
It is a vertical shrink
Shrink. Good choice of words.
of 0.73.
Thank you very much. Yep. 0.73 sine x. We were pretty close.
Yes. Next
All right.
is we'll do like
We probably need to do a cosine one.
that's next.
Okay. Now-
Number 9. So it's y equals cosine of negative 7x. And it wants us to find the period and the language of transformation, but we can also just find the amplitude.
All right. Say that again. Cosine what? Or y equals?
Y equals cosine of negative 7x. So in parentheses, negative 7x.
Okay. We will hold on to that and come back to that in a second. We need to know what a regular cosine function looks like.
Yeah. Which,
All right. So back to my circle.
I don't know.
X squared plus y squared equals 1. Okay. What cosine? Is it x value or y value? Or slope?
Cosine is y value.
It is?
I'm sorry. Cosine is x value. I don't mind me.
Okay. So the at 0, just like we did before. Oops, that should be a theta. Undo. Theta.
It's going to be the same.
And then x value. All right, so what is the x value at 0 radians?
0.
Nope, that's the y value. I need the x value.
Oh. That's
Think to your unit circle.
1.
It is 1, thank you very much. What about your x value at pi over 2?
0.
0. What about at pi? What is your x value?
Negative 1.
And at 3 pi over 2, what is your x value?
0.
And at 2 pi, what is your x value?
0, 1.
1. Let's graph these points.
Okay.
That's HK right there.
Yep.
The good old OG. Now, at 0, you said I plot 1. At pi over 2, I plot 0. At pi, I get negative 1. And at 3 pi over 2, I'm back to 0. And then 2 pi, I'm back to here.
I knew it.
So it is slightly different.
It's a boy.
What do you think the period is? I should say, what do you think the OG period is?
2 pi.
2 pi. So a modification of that would be 2 pi times the absolute value of A. Well, that sounds pretty familiar, doesn't it?
Yep.
Okay. All right. So what is the OG amplitude?
1.
1. That's true. That's true. So that means the amplitude for the other ones is going to be the absolute value of B, right? Well, that sounds really familiar. It's the same as on the sine function.
Yep.
Noticeably different, HK. HK sits on the center line, but it is not an actual coordinate on the graph. It sits under the max.
Under the max.
Right, just like Sebastian from the movie Little Mermaid. Didn't he sing a song about that?
Can't say I know. I don't really watch movies.
Oh, you don't?
Never.
Okay, wow. Now, what do you mean you never watch movies at all?
Like ever. Like I don't remember the last time I watched a movie.
Do you hate television?
I guess I just don't ever watch it.
Do you read books?
No, God, no.
Okay. So do you just play basketball all day?
Yeah, basically. Just kidding.
What do you do for fun?
I
can't-
watch TikTok.
Oh, gotcha.
Yeah.
So you have grown up watching TikTok, and do you not have patience for movies?
No, I do not. I
Okay.
have too much energy, and I just can't sit through a whole movie,
Wow.
and it just bothers me.
Okay.
I just want to get up and move.
Okay.
Yeah.
You are not like many of the other people that you grow up with.
I know.
Now, I mean, they like TikTok. I'm not saying they don't like TikTok, but
everyone likes TikTok.
except for me. I mean, I like the occasional TikToks that my boys bring me, but it's not my thing.
You say that. My mom said that too, and then she downloaded it, and it was life-changing.
Really?
Yeah.
Yeah, but China knows where, you're doing everything.
They know it now already, anyway. They know what I'm doing, even if I don't have TikTok.
Okay.
It's not like I'm doing anything exciting.
All right, now. Y equals cosine x. There it is. It fits what we drew. I need to know how to get your question in fireproof form.
That's a good question. So it's going to be
Well,
y.
Yep.
Actually, I was going to do y over something.
Nope.
Okay.
All of your changes on this question involve the x value.
Y equals cosine of 1 over 7.
You're getting warmer. Yes.
Negative 1 over 7.
Um,
Even warmer.
we want 1x. Okay, we want this to say 1x.
Divide by 7.
You are getting warmer. Yes.
Divide by negative 7.
Hold on a second. Let me get some space here to write. Currently, you have negative 7x over 1.
Yeah.
We multiply by what?
1/7.
Negative 1/7. Right? So if we multiply this by negative 1/7, top and bottom, we end up with x divided by negative 1/7. So this is fireproof form.
Okay.
Oops. All right. A, B, H, K. What's A?
Equals -1/7.
Good job. B.
B equals 1.
Amen. H and K?
Equals 0.
Yep.
Are they always 0?
No, they're not. But remember, we're starting out slow.
Okay.
So, the roller coaster, pun intended, will continue to get more difficult.
Okay.
So, we find our HK, which in this case is 0, 0, sitting right on the center line. Right? Y equals 0 is your center line of your wave. I often have my students graph the center line of the wave first. That way they know everything is going above and below that dotted line.
Correct.
Then I have them find HK. Then I have them use the amplitude. Oh, by the way, what's the amplitude here?
The amplitude is 1.
Yes. And what is the period? Oh, this is going to be ugly.
No, it's not. The period is pi over 2.
Nope, I believe if we follow this logic right here,
Okay, so 2 pi
times 1/7, which is over 7. That's ugly. 2 pi over 7.
Wait, where are you?
Okay, up here in the upper right.
7.
Right, aren't we doing 2 pi times the absolute value of -1/7?
Yeah.
So what do you get when you multiply 2 pi times the absolute value of -1/7?
It's 2 pi 2 times -1.
Well, the negative drops, right?
So 2 pi
2 pi times 1 across the top and 1 times 7 across the bottom.
You get 2 pi over 7.
Yes. 2 pi over 7 is not one of the nice ones that we have kind of memorized.
No, it is not.
So it's kind of ugly.
Yeah.
Is this going to be a horizontal stretch or shrink? Horizontal stretch or shrink?
It's going to be a horizontal shrink.
That's right, because 1/7 by 1/7 is less than 1. So it's definitely a shrink. So quite a bit, actually.
Yeah.
What does the negative do?
It makes it reflect over the x-axis.
Reflects, let's see, we're changing the x value.
So reflect over the y.
Yeah, we're reflecting across the y-axis. Across the y-axis. Whoa, I can't. I'm too close to the edge. Ugh. Reflect across the y-axis. Oh, let's get rid of that. Well, you're never going to notice that reflection across the y-axis.
Correct.
Because when take this graph and reflect across the y-axis. It's going to stay exactly the same. I mean, you'd have a point here that would reflect across here and a point here that would reflect. It would look exactly the same.
Exactly.
So we won't even notice a reflection. We would notice a reflection across the x-axis, but we're not even doing that.
Yeah.
Now, that being said, if you reflected a sine wave across the y-axis, you would definitely notice.
Yeah.
There's a particular reason why you won't notice this reflection. So we have x divided by negative 1/7.
Well,
Remember we said it was a horizontal shrink? And significantly?
yes. Very significant.
If you did a horizontal shrink by 1/7, doesn't that mean 1, 2, 3, 4, 5, 6, 7 cycles in the same amount of space as the original function?
Yes.
Kind of makes sense. So, your language, we wrote out the language, horizontal shrink by 1/7, reflection across y-axis.
Correct.
Does this kind of make sense?
Yeah.
Okay. All right. What's next?
Should we?
Oh, we should probably review.
Yeah.
Okay.
That's what I'm thinking.
Yep. That's a good. Here, I'm going to stop my share and let you share.
So.
And then you can ask me for certain things.
Draw, I guess, because I have to make my own unit circle.
Okay.
So I kind of am familiar with the pies, but knowing the sine and the cosine is what I kind of want to do again.
Okay, so your sines and cosines. 1, 2, 3, 4. Take the square roots. Divide by 2. We got 1/2. We got radical 2/2.
Yeah.
Radical 3/2. And 1. These are the most popular on the circle.
I remember doing those all the time.
Now, it's so much nicer if you just give yourself a circle.
I can't do that, can I?
Yeah, you can use the circle tool.
I don't think I have that.
You don't. If you have the annotate bar and you hit the draw button where it has the little squiggly, do you see that it shows up with several options? Yeah, see there, you drew your own circle. Here, I'll get rid of mine if you want.
Oh.
But see, that comes in real handy to draw, to draw on screen. There you go. Okay, so draw your own axes.
Okay. Well.
Nice.
And then I know it goes like this. And
Okay.
I know this is.
Now, I like, let's see. I like the one in the middle, right? That's 45 degrees.
Okay, it's not drawn to.
But
I just know there's 3 lines.
Right, but we've got 30, 45, and 60. Don't they kind of have to be huddled a little bit closer in the middle there? Because this is 0 to 30, and that's 60 to 90. Right?
Yeah.
So the 30, 60, 90 have to be kind of evenly spaced out with 45 running right down the middle. Now there's a reason why it seems like I'm being picky about that.
Okay.
Okay? So that when you start drawing your X's, you've got your 4 numbers right there, right? 1/2, radical 2/2, radical 3/2, and then on the outside edge 1. Does that make sense?
Mm-hmm.
What does that mean? Mm-hmm.
It does. I'm just concentrated on writing what you're doing. So sorry.
Okay.
Yeah. Yes.
Well.
X is cosine. So the cosines.
Right. Those are the cosines.
Okay.
So
And
now when you say you have to make your own unit circle, are you saying just for your own reference sake, or are you saying that's an actual test question?
like for my own reference sake.
Okay. Well, truthfully, as long as you can make quadrant 1, you'll really kind of have everything else you need.
True.
Because, if
It's
they're
all the same.
right, they're all going to be either positives or negatives of these numbers. Now, those are sines and cosines. What about the popular tangent numbers? Well, what's the slope for 45 degrees?
45 is.
Right down the middle. I'll draw the line
I know
for you.
that's 1.
Yeah, it's a 1. Right, so that's the popular tangent right in the middle. Then there's 2 others, one bigger and one smaller. What's the bigger one? You got 2 choices.
60 degrees.
You got radical 3 and radical 3 over 3. Now you're
Radical
right
3
that it happens at 60 degrees. But is it square root 3 or radical 3 over 3?
Square root 3.
Good. And then at 30 degrees, we're radical 3 over 3. Well, literally, those are the most popular tangents. Now, yeah, let's not forget, this one's a slope of 0. This one's a slope that's undefined. So those are values that you need to know. But, I'm hoping... What?
Sorry, go on.
Well, I mean, you do know that a horizontal line has a slope of 0, right?
Yeah.
And that there's no slope for an undefined tangent. A vertical line has no slope.
Okay.
Have I talked about that with you?
Mm-hmm.
Okay. So I assume those are the ones, the most difficult, I guess the trickiest ones to remember are the 1 radical 3 and radical 3 over 3.
Yes.
So I guess I'm assuming that the other ones are kind of known.
Oops, sorry.
Is that make sense?
Yeah.
Okay.
And then this is pi over 4.
That's true.
Would this one be pi over 3?
No, that's pi over 6.
Pi over 2. So
Okay.
that's pi over 6 and that's pi over 2? No.
Let me, oops, I don't want to clear everything out here. You know what? I'm going to do my own circle over here.
So this one has to be pi over 3.
And do you want me to count around the circle in pi over 6s or pi over 4s?
6s.
Okay. 0, pi over 6, 2 pi over 6. Now, have I counted around the circle with you like this? 3 pi over 6. So if I was making my unit circle on the test, I could at least do this. Now, if I want to reduce them in my head, instead of calling that 4 pi over 6, I could call it 2 pi over 3. So I could reduce it. But notice as I go around, 6 pi over 6. Yeah, that's just pi. And then 7 pi over 6. And then 8. And then 9. And 10. Oops, sorry. My 10's a little bit farther than it should be.
All right.
But by doing that, I get most of them right there, right?
Yes.
And the only ones I've missed are these. 2. Oops, missed.
Oh, so pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4.
Yep. So, yep, you got your 1 pi over 4. 2 pi over 4 is at the top. 3 pi over 4. 4 pi over 4. Yeah. And then 5, 6, 7, and 8.
Okay. So.
But literally counting is the way to go.
Yeah, agreed.
because as soon as you do what you did, and I'll try to not to erase what you wrote. That's a little bit hard.
That's all right.
But so maybe it'll only erase mine. No, it'll probably erase yours too. But you're trying to figure out, is this one pi over 6 or is it pi over 3? Well, if you literally had counted around the circle in pi over 6 increments, 1, 2, 3, 4, 5, and so on, you would have known which one was called pi over 3 because you would have reduced 2 pi over 6 and gotten pi over 3.
Okay.
And then you don't have to accidentally write the wrong one.
Okay. That helps. I just needed a refresher on that. And then there's one other thing I want a refresher on before we leave.
Okay.
Let me see if I can get out of this. Can you see what I'm doing if I get out of that?
Yeah, I can. Do you want me to clear this off or leave it?
You can clear that.
Okay.
I gotta find it. It's like converting RAMs or RPMs.
Yes, this one.
But this is miles per hour. I want the RPM one.
Oh, you want it to start in revolutions per minute?
Yeah.
Okay.
I can't do that.
Yes, you can.
Can't
Okay.
a strong word. I don't remember how to do that.
Okay.
Okay.
All right. So, have you found it yet?
Oh, sorry.
Or do you want me to make one? I can make one.
Can you just do that? I don't know if I want it specifically in this.
So I don't know if this is going to be good. Let's go with 1,000 revolutions per minute.
Okay.
Okay, and we're going to say that the circumference, let's see, the radius of this is, let's go with a radius of 15 inches. So what's the circumference?
30.
30 pi inches. So 30 pi inches is the equivalent of 1 revolution.
Okay.
This is a very, very important fact. Okay?
And that's always.
Well, the circumference of the wheel or the tire is always equal to 1 revolution.
Okay,
Every time the tire goes around one time, then you're saying that the vehicle, the bicycle, the motorcycle is going 30 pi inches.
So, like in this case, 26 would be it.
That is, yes, so it would be 26 pi inches.
Got it.
Okay.
Right.
Now, if I'm changing 1,000 revolutions per minute into miles per hour,
yeah,
then we need to multiply, right? We're doing factor label method. If I'm doing miles per hour, then I got to get the minutes to be converted to hours, right?
Minutes to hours. Yes, so it'd be like minutes on top.
Miles per hour.
So
60 minutes
on top
is the equivalent of 1 hour of time.
Oh,
and
God.
so the minutes are gone.
And then you have to do hours by seconds.
Okay, now, we want to get rid of revolutions, right?
Correct.
So 1 revolution is how many inches?
30 pi.
30 pi inches. So now I see the revolution units cancel. So you see how I'm getting rid of the things that I don't want and converting to the things that I do want. Okay, now, if I'm trying to get to miles, then I'm going to have to change inches into feet first.
Inches into feet. Okay.
So this one has to have feet and inches.
Inches on the bottom, right?
Inches on the bottom. 12 inches on the bottom, 1 foot on the top. Okay, so that gets rid of my inches units. Now I need to get feet into miles.
Oh, God.
How many feet are in 1 mile?
I know feet's gonna go on the bottom. How many feet in 1 mile? Oh my god, I'm in the 36?
I want you to read this at the bottom of the screen.
Oh no, am I embarrassing myself by not knowing this?
Well, they did teach it to me in elementary school, but you obviously were not taught this because it would have stuck with you for a long time.
Yeah, I've never seen 5 tomatoes. I mean, I've seen them in life.
Okay, now say it slower.
5 tomatoes. 5, 5, 2, 8,
Tomatoes. 5280, 5280, 5,280 feet in 1 mile.
Okay.
5 tomatoes. So,
I'm gonna remember that now.
good. 5,280 feet.
In 1 mile.
1 mile. So now the feet units, oops, hit the edge of the screen. The feet units cancel out. So now the only thing I have left is miles on the top and hours on the bottom. Now it's a matter of doing the multiplication. I've got 1,000 times 60 times 30 pi, that's on the top. And on the bottom is 12 times 5,280. If you want to save yourself a lot of trouble, use parentheses.
Okay. Parentheses, like, in everything?
Well, do you see where I put the parentheses?
Oh, okay, yes, sorry.
One for the numerator, one for the denominator.
60 times 30 times 5 tomatoes. 89 point, let's round to the nearest hundredth. 2, 5.
So doing 89.25 miles per hour. That bicycle's moving.
Yes, it is.
I just randomly, I didn't know what it was going to be. I just chose 1,000 just to see what it would be like.
Okay, so here's the thing.
Yeah.
Never mind, I guess. So I have to cancel out everything except for the revolutions.
Well, revolutions
Wait,
canceled out.
Wait, hold on.
We wanted miles to be the only thing in the top, hours to be the only thing in the bottom.
We want, okay.
Based on what the problem you designed for me and wanted me to do with you, starting in revolutions per minute and converting to miles per hour.
Okay. Okay. I think I should get that then. I'm a little bit nervous for this test quiz.
Anything else, or are we done for the night?
I think we're good.
Okay. All right. So let me just quickly look at my calendar and make sure. So we're doing Mondays or Sundays and Wednesdays. Is that true, or am I or are we just going week by week and you tell me what you need?
How about we do week by week because my games change?
Right. Do you want to keep the Sunday time slot?
That would be great.
Okay. All right. So.
And do you want to do 7 to 8?
Yes. So I'm just going to duplicate this and put you down. That's our third, and that will be for the 23rd. I just want to get it saved so that you're on the calendar for next Sunday.
Agree.
Okay.
All right. Thank you.
All right. Well, let me know how things go.
I will.